So everything that we were doing last week in section 6.1, the problem started out with an inverse. It would say something like cosine inverse of 1/2 equals x. And when we saw that cosine inverse, we knew that we were limited in our quadrants, right? If it's an inverse, well, it could be quadrant 1 or 2 for cosine. Since it was positive 1/2, it was quadrant 1. And then we are asking ourselves, okay, this is just like saying cosine of some angle x equals 1/2. What's that angle? So when is cosine 1/2? 60 degrees. All right, we're solving something similar today, but the original problem will be different. The original problem will be something like cosine x equals 1/2. Okay, kind of the same thing, but you'll notice this one does not have an inverse. That means I can get more than one answer. So I have to think about every time cosine is positive. When is cosine positive? Reference angle. When is cosine 1/2? 60 degrees. So 60 degrees in quadrant 1 is 60 degrees. In quadrant 4, 360 minus 60 is 300. Okay. Does everyone see the difference between these two things? Both of them were just finding an angle. If the original problem has an inverse, you will only get one answer. We're limited on our quadrants. If the original problem has a normal trig function, not an inverse, you will get multiple answers every time that happens. Okay? This all boils down to knowing your unit circles, just like the last section. So, if you rely on that unit circle, make sure you know how to fill out a blank one when we get ready for a test. If you use your hand trick, make sure you are familiar with that. If you are rusty on any of those things and need help, see me sooner rather than later so we can go back through it, okay? So let's take a look at our first problem. I want to solve 3 tangent theta.
You already started this.
Oh, we did start this one, right? I did 2 examples with you guys. Okay, we did this one and this one. Did I do this problem? Okay, good. Let's go to this problem. Am I in degrees or radians? Radians. Do I have to do all possible solutions on this one? I only said between 0 and 2 pi. So every time between 0 and 2 pi that it happens, so I'll probably get multiple answers. But remember, it's been a while, Thursday, sometimes it said for all possible answers and we had to put the plus 360 degrees k or plus 2 pi k on the end. We wouldn't have to do that here because I only want the ones that fall between 0 and 2 pi. So just one time around the circle. Okay, so we looked at problems where we just had one trig function and we just tried to get it by itself. And then we looked at some where we had multiple trig functions and we were able to factor something out. I have multiple signs on this. I don't have a greatest common factor. I can't just get sine by itself. What do we do? Slip and slide. This is a quadratic. Okay, so this would be sine squared x minus sine x minus 6. So that factors into sine x. Multiply negative 6 and add to negative 1. So negative 3. Positive 2. And then we start out multiplying by 3, so we divide by 3. So sine x minus 1 and 3 sine x plus 2. get it factored, what do we do? Mhm. So sine x equals 1. Okay, you can think about your hand trick when sine is 1. You can think about it on the unit circle, sine is the y. There is only one time when y is equal to positive 1. Where is it? 90 degrees. Now we said we are in radians, so I would answer that with pi over 2. Since I didn't say all possible, that was it. If I said all possible solutions, you would just put plus 2 pi k, because all the way around the circle is 2 pi radians. Alright, let's look at the other one. When is sine negative? Three and 4. Reference angle. Do you know when sine is 2/3? Is that one that we had on our hand trick or a circle? No. So we have to use the calculator. Alright, we are in radians, so start out putting it in radian mode. Then how do we type this in? If we're looking for an angle, what do we type in? Yeah, the inverse. So second sine. And we're looking for a reference angle, so put in the positive 2/3. So we get 0.7297. Alright, in quadrant 3, so think about radians. I've told you that this little angle right here is 0.7297. You need the whole thing, so you have to add pi to that. So pi plus, that gives me 3.8713. And in quadrant 4, we have this little angle. How do we get the whole thing? Subtract it from 2 pi because we're in radians. 360 if you're in degrees. So we got 3 solutions there. Again, if I hadn't specified that it was only between 0 and 2 pi, if I had said give me all possible solutions, you would have to put a plus 2 pi k on the end of each of those, and then tell me that k was an integer. Why don't you guys try one?
You don't do anything with this negative, since I'm saying.
The negative is what told us the quadrants. So you guys try this. So, well, side note, we'll go back to think about the beginning when we first started talking about quadrants and reference angles. Okay, so we have our circle. In quadrant 1, your reference angle and your angle are the same. Okay. In quadrant 2, all right, think about if you go all the way around, if you're in degrees, this is 180 degrees, right? And it has to be smaller than that. So if you're in degrees, it would be 180 degrees minus your reference angle. If you're in radians, 180 degrees is the same as pi minus your reference angle. In quadrant 3, you're going past that mark. So if you're in degrees, 180 plus, oops, that's supposed to be reference angle, sorry. Your reference angle, if you're in radians, it would be pi plus your reference angle. In quadrant 4, think if you go all the way around, you're back to 360, but we're a little bit smaller than that. So your angle is 360 minus your reference angle, or if you're in radians, 360 is 2 pi minus your reference angle. So that's how we put it in the correct quadrant. Questions there? Is that a good refresher? You remember? Remember the all students take calculus tells you when things are positive. They're all positive in 1. Sine and its reciprocal are positive in 2. Tangent and its reciprocal in 3. Cosine and its reciprocal in 4. So if we look at this one, we are set up to factor. Tangent squared breaks into tangent. Okay, what multiplies to -2 and adds to +1? So if you set those equal to 0, you get tangent x is -2 and +1. I expect to see quadrants and reference angles when you're working these out. So this one, tangent is negative. When is tangent negative? Reference angle. Do we know when tangent is 2? No. So we go to our calculator. We are in radians, so make sure you're in radian mode. We need to do tangent inverse, so second tan, and do +2. So you get 1.1071. So our angle, to put it in quadrant 2, we're in radians, so we said that's pi minus our reference angle. So pi minus 1.1071. Okay, in quadrant 4, what do we do? 2 pi minus. All right, so those two answers came from here. Now I need to deal with the other one. So, quadrants. When is tangent positive? Reference angle. When is tangent equal to 1? 45 degrees, which in radians is pi over 4. So, pi over 4 in quadrant 1 is still pi over 4. In quadrant 3, you can remember the pattern. The third quadrant at the top is 1 more. You could think pi plus pi over 4. We get 5 pi over 4. Is that okay? Let's look at some more. If I'm looking at this, it's kind of factored. But factored form really only helps us if it's a 0 on the other side and we can set each one to 0. So does this factoring help me at all? No. So what we're going to have to do is multiply it back out. So if I distribute, we get cosine squared x plus cosine x. Can I go ahead and subtract this 2 over? So now it's just like the last problem except cosines instead of tangents. So cosine squared breaks into cosine. Multiply to a -2 and add to +1. +2 -1. Cosine x equals -2. When is cosine negative? Reference angle. When is cosine 2? So if we don't know, what do we do? What does it tell you? Error. Remember when we graphed cosine, it always fell between -1 and +1. If you think about your unit circle, cosine is the y, or the x. The biggest x we hit is +1, the smallest is -1. So can cosine be a -2? No. So we're just going to ignore that one. Doesn't help us. Cosine x equals 1. Okay, think about on the unit circle. Cosine is the x. When is x +1? X is 1 right there, isn't it? Cosine of 0 is 1. I didn't specify. Let's do degrees. 0 degrees. I said all possible solutions. So what would I put on this? And you need to write out that k is an integer, so you can put it in words. Shorthand notation, you say k. You make this curved-looking E sign, and the integer symbol from algebra was a double-barred Z, so you can write it like that. That's the shorthand. It just means k is an integer, or you can write in words. K is an integer. Would you have to leave this as 0 plus 360k? No, 0 plus anything is itself, so you could just write 360 degrees k. Every multiple of 360, cosine is going to equal 1. So as long as you have an equivalent form, that's fine. Let's find all radian solutions to this equation. Okay. What would we do here? How is this one different than the others? Two different trig functions. Do they have a greatest common factor or anything? No. But we've done identities. Yeah, pull out those flip charts. All right, so what could I do? Okay. So now what? They're on the same side. So if I add over my sine squared, that gives me a 2 sine squared theta. If I subtract my 1, those cancel. Divide by 2, I get sine squared theta equals 0. Get rid of the square. We square root plus and minus, but that's just 0. So sine of theta equals 0. When is sine 0? Zero and 180. If we're in radians, that's 0 radians and pi radians. I said all solutions, so you'd have to say plus 2 pi k with each of those. 2 pi is the radian equivalent of degrees. Now there are other ways you could write this. 0 plus 2 pi k is the same as 2 pi k. You might, if you're looking in the back, it might just say pi k, because this happens every multiple of pi. As long as you have an equivalent form of describing the solution, that's fine. I'm not going to be picky about how you do it. Why don't we go ahead and just stop here for today? So I'm going to give you the assignment already, and you've got a little time to work now, not a ton, but about 15 minutes. It's not going to be due until Wednesday, so tomorrow we'll do some more practice, and you'll have some more time to work on the homework, so you don't have to take it home and finish it tonight. You can get started while you're in class, and you'll have some more time tomorrow. Okay, make sure you're watching. It's every other odd, so don't do more problems than you